Good morning. This is Sharad Gutikunda from Urban Emissions India. I'm covering the topic data gaps and resources to support short-term air quality forecasting and long-term pollution management. COVID-19 and air quality made a lot of headlines in 2020 and 2021. This also highlighted some missing links and provided some opportunities to study new themes. These are some snapshots from India's first lockdown in March 2020. All the cities experienced these blue skies and clean air days. This was possible only because of direct reduction in emissions from almost all the sectors. Road, rail, aviation, and marine transport was disrupted. Most of the commercial cooking activities and to some extent, some regular residential cooking activities were also halted. Most of the industries were shut, and there was a reduction in the power generation rates before it would pick up again after a couple of weeks. Except for natural sources like dust, open fires, sea salt, and lightning, everything else saw some form of reduction, and it immediately translated into pollution reduction across the country. This was evident in all the satellite observations during this period. Here's a summary from Modi's satellites, courtesy of Pawan Gupta at NASA. These reductions were significant, and as time passed, the numbers also reached the old normal levels. The small animation at the bottom, this provides a quick snapshot of the data that was collected by the Central Pollution Control Board for various cities and how the air quality, especially the PM 2.5 concentrations, changed over 4 different lockdown periods in 2020 between March and May. Two key lessons from this episode. Emission regimes changed during this period, providing support to interesting atmospheric chemistry lessons, like what happens to ozone when there is a sudden drop in NOx emissions. We've noticed that in some cities, NOx has increased, ozone has increased, some cities, ozone has decreased. So obviously, there was a big shift in the NOx to VOC ratios and how it affected the photochemistry in those regions. And a very important lesson is air quality can be bettered only if the emissions are dropped. So it's really important that we keep that message in focus. So in this presentation, I want to highlight 3 themes to address the data gaps and opportunities that are coming up: ambient monitoring, emission hotspots, and chemical transport modeling. Theme 1, monitoring efforts. One question we always get is how many monitors are required for a certain area or a city. For an emissions and pollution modeling person like me, this answer is always as many as possible, and if possible, one every square kilometer. But we all know that it's not possible financially and likely operationally as well. Monitoring data is crucial for air quality forecasting and also for policy purposes. It helps in identifying the temporal trends and sometimes directly linking it to the sources that we have in the city. And a large network is certainly helpful in understanding the spatial trends of pollution better. There is a large gap in the size of monitoring network currently operational and availability of the monitoring data as well. The background map is from openaq.org, looking at all the stations where official data is available. Here is an example from India and China. There are 304 continuous monitoring stations running in India as of November 2021, and this is against 1,500 stations running in China. This number translates to 0.2 monitors per million population, which is not a very good sampling size. Going by India's own thumb rules, set by Central Pollution Control Board, we require a minimum of 4,000 continuous monitoring stations running in the country to spatially and temporally represent what we are seeing. This gap is now being filled with sensor networks and reanalysis fields using a combination of global chemical transport models and satellite feeds. For the time being, this is able to answer the question of how much the pollution is with some level of confidence, but there is a long way to go. And to operationalize these networks for forecasting platforms, I think there's a lot of work that needs to be done at the same time. For India's NCAP, the National Clean Air Program, covering 132 cities, we did an assessment of monitoring effort needed and the current capacity in the country in each of these cities. And this current capacity is less than 5% of the required minimum to spatially and temporally represent what we are respectively observing in each of these cities. So there is definitely a big gap, and the opportunity is in building the sensor networks and also trying to integrate some of the new satellite feeds that are coming in for operational purposes. Theme 2, emissions hotspots. Some sectors have evolved over the years in building a reasonable emissions inventory. Now, for example, fires using feeds from MODIS and WEAR satellites. These are fully integrated into the stories by the media and also by academic groups equally. However, there are still some sectors which are not mapped properly, and the uncertainty is still high in their inventories. Here are three examples from India, but the same is true for many other countries in Asia, Africa, and Latin America. If these emission hotspots are missed, it leads to uncertainty in the inventories and any of the conclusions that follow for long-term policy making. Here are some sources mapped for the city of Mumbai, which definitely needs more scrutiny going forward. This is a freight hub near the port, covering an area of 1 square kilometer, with equivalent of 5,000 trucks going in and out every day, with and without cargo. So there's a lot of activity. So that means a huge hotspot with vehicle exhaust emissions and a lot of resuspended dust. This is definitely needs a bit more analysis on how many trucks actually are there and processing in this area. The port activities themselves are spread across 6 square kilometers. So this is not just the ships that are coming in for loading and unloading, but also a lot of activity from rail and from road that needs to be mapped. This is one of the largest landfills in India, covering 1 square kilometer area, where burning instances are very regular feature. In this map, this is from Punjab. Each of the red dots are fixed chimney brick kilns in the state of Punjab, approximately 3,000 of them, with several of them away from the urban agglomerations. This makes it difficult to track and report their emissions and contributions. Over the years, some kilns have moved or closed, which means that we need more effort to regularly update this kind of databases. The kilns in Punjab were easy to spot even with a manual scan, but there is also clamp style kilns which are stacked bricks and burnt for 10 to 15 days. Here's an example from outside Mumbai. These are not easy to spot as they move around very often. Here's an example from outside the city of Pune, quarries covering an area of 11 square kilometers. Zoom in and you will notice several unofficial and off-grid activities, all of which contribute to emissions and associated uncertainties. This includes blasting, crushing, loading, and transporting activities. For an urban area of interest, it would be easy to update with a quick scan of the area and spending a day or two to physically inspect and assert their existence. But for a regional or national scale assessment, we need new methods. Google Earth Engine imagery and other feeds are evolving, and they have evolved over the years, and a lot of these feeds are available for free. And hopefully, we can use this as an opportunity to fill more of these gaps going forward. Even in the transport sector, we need more information on how and when the vehicles move to reduce uncertainties in the emission inventories, and consequently leading to better air quality forecasts for 1 to 3 days. I mean, this is really important on a short-term basis because transport does play a big role on an hour-to-hour basis, and to get that right is very important. Google Maps and a couple of other services are providing this information, that is speeds at various locations in the city at various hours, but that comes at a cost. There is also a lot of room to improve on these efforts and further investigate them into real-time forecasting. Finally, air quality modeling itself. Most of the modeling work is available as reanalysis fields from global models using global and regional emission inventories. While these are good for understanding the trends and general pollution loads, they are not as equally useful for urban air pollution management, which requires similar modeling efforts at a higher resolutions and more customized for the airshed itself. So this step is not only a data gap issue, but also a capacity to conduct issue, which needs to be addressed at the institutional level. In the academics, We often see case studies from big cities, repeatedly from big cities. This needs to change, and focus on tier 2 and tier 3 cities needs to be more at the core front, because these are cities which are following in the footsteps of tier 1 cities. And here's an example. We have a program called Apna City program, where we covered 50 airsheds, and they include about 60 cities. And the India's NCAP program has about 132 cities. I mean, there's still a long way to go. A lot of databases need to be customized for the cities, for the city authorities to take this forward. So there is a lot of data gaps that we're trying to address, but there's still a lot of gaps there. And a lot of this new age information available is providing us more opportunities to address these gaps. Thank you.